So this machine doesn't come with any build guide hard copy. You have to access that from the website. So it's handy to have a PC, laptop or anything handy to review the build guide as you're going through. So in my case, I'm gonna have this handy dandy workshop laptop sit next to me, and I've decided to proceed with the control box. So that is my plan. We'll start with the electronics. I've got the 2 boxes with the majority of whatever's going to end up in this box. So we'll do that, and then we'll move over to the hardware in another video and assemble the machine. Don't you hate it when you've recorded about 5 minutes worth of video and forgot to turn your wireless mic on? Anyway, if you hear fan noise in the background, I must apologise. It is roasting hot in here. It must be about 100 degrees Fahrenheit or 38 to 40 degrees. The old workshop is insulated, but we've had a heat wave over the last 3 or 4 days, and it's just compounded every day. It doesn't normally get this warm in here, but heat wave, what are you going to do? Just got to lump it. In my Charlie Chaplin video, there was no audio. I've just taken the control box apart. So basically the top lids come off, and each screw point has an insert, which is just a mark of quality. That is just fantastic, because if you relied on the thread to remain in this 1mm, I guess, maybe more, 1.2mm aluminium plate, threads wouldn't last 5 minutes and you'd rip them out. So these little pushed in nuts on each of the connection points is just genius. So that just shows you the quality and thought going into this project, into this product. So that is impressive. So my main aim today is looking at all the parts that we need to get into our control box, follow the build guide as best we can, and then yeah, this will form our first video, basically the building of the control box. Let's get started. Just a note, I'm not following the build guide in order, because the first project is building up the gantry side plates. Like I said, I want to start with the control box and we'll go from there. It's going to be a bit of a chop and change. I just want to get this done and then we can work on the mechanical side of things afterwards. Okay, let's have a look at the contents. Connectors and switches. Right, so box number 4, there is our main control board, some of our connectors, and for our wiring loom. That'll come in later anyway, so we'll move that away. Okay, e-stop switch that goes on the front panel. A couple of cable glands, which will be for the rear panel, which is where our cables enter and exit the control board. Our 50mm fan for cooling, and a little 50mm cover with filter. Very good. Okay, momentary switch, yellow, a green momentary switch, 10mm cable sock. I guess we won't be needing this for the electronics board, but this is a G2 belt, 4 meters. 3mm cable sock, sticky pad feet, it goes on the bottom of the enclosure. 4 micro switches, so this will be our limits. 2020 right angle gussets, this will be for the base structure of the actual machine, so we won't need that for the electronic side of things. And the USB cable with gland installed. Oh, how thoughtful. So because you just can't go cutting off USB plugs and expect to get them back on neatly, they've actually pre-installed the cable gland onto the cable, so you don't have any joins and anything to worry about within that USB cable. Because this is a signal carrying cable, the last thing you want is homemade joins, and this could introduce faults. So that is a nice touch. I'm really impressed that they've actually gone to the trouble to put the cable gland on the cable before factory fitting the plugs. Oh, that is impressive. Okay, let's start with the most obvious and easiest one, which is the e-stop. Now I've installed a few of these in my time, so let's see if this is similar to what I already know. That should screw off. Yep, then we got the chromed collar that comes off, so you'll see that on the outside of the box. And on the inside you'll have a rubber grommet and an adjustable collar. Depending on the thickness of your panel, you would adjust this. Is that even in focus? Yeah, you would adjust this to suit the thickness of the panel that you're installing it to. Okay, so that is pretty much where we need it. We can adjust that once we get the silver collar on afterwards. So through there. Easy. So now we've got, oh, panic attack, hit the button, everything should shut down. To reset, just turn the dial and your switch will then pop back out ready for the next emergency stop. It's pretty nifty. So get used to the location of that button, because if you start crashing something, that's what you want to hit. Okay, the green switch, which is feed hold, and no, green switch would be resume. I'd imagine the yellow would be feed hold, which is generally the color code of these. Well, not really. The green would be cycle start, but you start the cycle within the software, I would imagine. So I'll quickly fast forward through the install of these switches because they're fairly straightforward. So because these buttons are just push button momentary type, don't over tighten the nuts on the back because you're not relying on any sort of turning motion on the buttons themselves. These fine threads on the rear of these switches are very, very fragile. As soon as you over tighten, that's it. They're very unforgiving. So just finger tight and that should be suffice. So that's the front panel pretty much assembled. Fairly straightforward. Excellent. So now we'll look at the main chassis and we'll look at putting in our control board, fans, or the fan and its filter, cable gland, and possibly fitting the USB cable as well. Okay, to fit most of the hardware into our base enclosure, we're going to need a 2mm Allen wrench and a 5mm finger ratchet or ring spanner or open-ended spanner. My spanner set doesn't go any lower than 6mm, so I've managed to find a socket and this handy little finger ratchet. Which will help us do up some of the smaller screws. And just to note, this kit doesn't come with any tools, so you need to be prepared and have Allen wrenches, probably the standard metric set, which I think is about 10 wrenches or so, Allen keys or Allen wrenches, whichever you want to call them, to get this job done. Otherwise, you're not going to be able to do up any of the screws because I think they're all Allen type screws. Okay, so we are going to install the fan into the sided enclosure. So the fan comes with a cover, and within that cover we have a filter. So this would tell me that this is an intake. The fan will take air in and it will vent out the other side. You can see these openings here, this grill, because I'd imagine why would you filter the output if you're taking in raw, untreated air, unfiltered air on this side? Especially if you're milling aluminium or anything metallic, the last thing you need is anything getting sucked in through the intake and ending up on your control board, because that will generally end badly for most people. So we want to filter anything that's coming in and take those particles that might cause us issues out of the airstream. This clips over the fan itself. No, it's got an insert. So if we look at the fan, you'll see an insert inside. So we should be able to just push that out. And this is important because you need to put your screws through the insert, through the back plate, and the filter cover clips on over the top. So you've got the two parts, and inside that is a foam medium. So we should be able to knock that out. And that provides us a bit of security and peace of mind that we're not going to take anything in through the intake that's going to land all over our control board. So you can see our main fan hole here, and we've got 4 holes which should match up. Now I think this will go over the outside of the hole, and you can see we've got countersunk holes either side, and then we've got our filter mesh that goes over that or inside our retainer, and then that clips on over the top. So this can be changed from the external side of your case, and within that the fan will go on the inside, making sure you have your direction of airflow, which is normally marked on the case. In this case it's not, but the general rule of thumb with fans like this, the side where it has the retaining for the motor for the fan is the direction of airflow. So it will always go from the open side and come out of motor side. That's normally the direction. If it turns out that's not the case, well then you'll have to physically take the fan off and rotate it. But generally, in my experience, this side where the fan motor is the direction of flow. So it's coming out this way all the time. And that's what we'll do here. You can see that we've got it this way, not this way. So the other way around, we'll get our screws. In this case, it's the socket flat countersunk head cap screws, M3 by 20 millimeters, and there's 4 of these. And backing that up is prevailing torque or nylock nuts, the same M3 by 0.05 thread pitch. And we'll get them out. So I'd imagine bolt, outer casing, through the enclosure, through the fan, and then into one of the prevailing nuts, prevailing torque nuts, which is the nylock. I'll just make that finger tight for now. In fact, I'll get the other top screw in, just loosely. Pick up the fan from the inside, get our next nut, screw that on. I'll do all 4 and then I'll show you what it would look on the inside. So this, while I'm doing this, is a bit of background on this particular router. It's based on the x-carve, I believe, by the Inventables, which is an open source platform, but this model's had specific updates and modifications made. I'm not overly familiar with the x-carve, so I couldn't tell you off the top of my head what those changes and whether they're improvements or just, you know, a 3D Tech's sort of spin on the whole platform. But it'd be interested to see what you guys think if you've got experience with the x-carve model. So there's our fan installed, just loosely at the moment. You can see that the motor's facing in towards the case, and then your control board would be here, and hopefully where the airflow is pushed across the board, it's going to pick up those heat sinks on those control modules for the steppers and then cool them down as it's filtering through. I have no idea what the flow rate or the CFM airflow rate of this fan is. It is a sleeve bearing, so it's nothing too special. It's not a maglev, but these fans are ubiquitous. You could pick them up anywhere and replace it if you needed to down the track. So I'll quickly just zip them up. Perfect, happy with that. So then we fit our filter, put our filter medium. You can see it's, I don't know if you can see, it's fairly open weave, which is great. It's not going to restrict too much airflow, but it will be enough to stop those nasty particles getting in. Push it in the corners. Pretty sure you can get this filter medium off eBay fairly cheap if you needed to replace it, but you could clean it. I'd imagine it'll last quite a while. And then we push it on and clip it on. Beautiful, done. Now we'll look to putting the control board in. Okay, control board time. Now the orientation of this board would be probably important because we need to know and have it in such a position that the airflow from the fan is maintained across these stepper controllers, because that is key. If these overheat and start shutting down during a project, then you're going to miss steps. The project's going to be scrapped. So best way would be to look at this and see how it orientates against the fan. And I can imagine if you look at where the fan is in relation to those heatsink, it's pretty much on center to that fan. So that's where we want to be. Socket button head cap screws, M3 by 5 by 6. We need 4 of these to secure the control board. Just nipped up for the time being until we get them all located. I might change over to a Allen screwdriver because it might be a bit easier in this situation. This should be easier. Oh yeah, perfect. And one more to go and then we'll nip them up. You can see that the USB port is this vertical USB port here. It's opposite to where the cable comes in. You can tell that the USB cable is for this hole because it has to enter somehow, and that's what that slot is here, because we're not cutting the cable. So something has to give. Either you cut the panel or you cut the cable. It triggers my OCD a little bit about the panel having a slot cut in it, but at the same time, lesser of the two evils, because this is such a important factor. This needs to be a good quality cable. It's streaming data to the machine at all times during a project, during a cut. Okay, so we've nipped up, perfect. What we will do, I think we'll remove the rear panel for now. Keeping in mind this control box does not have any spindle control. With the optional spindle you can get with this machine, it's straight mains powered and you're switching on and off on the actual router motor itself. So this will not be controlling your spindle in that case. I do believe though there is an output Let's see, limits, ground power, yeah, okay. It does seem like this does have spindle control output. It may marry up with the spindle controller that I've got, being a brushless DC motor, so that will be controlled from this board. And that's part of the reason why I opted for that, because in the G code you can then set spindle speeds, start-stop rates, and all that sort of business, where you won't have that functionality using a normal mains powered hand router. So you have to decide which way you want to go. I've decided that I want to control my spindle through the G code, and later on down the track I'll show you how to set that up. Okay, I do have a slight criticism with the design of this setup at the moment. Because the fan is mounted on this side, the header for the fan connector seems to be all the way over on P19. I will just confirm that, but I'm pretty sure that's the only 2-pin header that seems to be the same pitch as this JST connector. I believe it's JST, it looks like it. Just be very mindful that you've got the polarity marked on the silk screen for this, that you want to make sure you get it around the right way, because these fans don't like to be reverse polarity. So red is towards the center of the board and black is towards the outside, and that seems to be where it goes. Tell you what I might do, I might route this cable under the board, pop it out the side here and then back over, so we don't have to worry about it flapping in the breeze. I'll just quickly do that now. It's not going to be that quick. Tell you what, if I go around this bit here, come through there and around this post, come out there, oh, look at that. Wonder if this was the design intent. That's pretty neat. Okay, making sure the polarity is right. Red to the center of the board, black to the outside. Yeah, that's much neater. Look at that. That might have been the actual original intent. You watch, I'll go and look at the assembly notes, and that's exactly what they'll say. Yeah, win. Okay, so we're going to take our USB cable. I really hope it lands on the right way. Okay, we want our USB-B connector, and we want the back of the, oh yes, the back of the gland facing USB, because that needs to be on the inside, as you can see, just like that. And then we'll take the nut off the back of the gland, slide our cable over and the gland back into the back plate, and then do up our nut there. Again, doesn't need to be over tightened. It's just a plastic thread. It doesn't need to be He-manned. And at this point, I think we can fit our back plate, because it's the last time we would need to take it off. Quickly zip them up. Again, well thought out as far as quality is concerned with these nut certs on all of these case connections. It's just going to add to durability and overall quality of the build. Very impressed. All right, nip those up, perfect. Now we can put the cable gland in. So we've got two. Looks like we've got a rather large one for all the motor outputs, and a smaller one for, what would that be? Limit switches perhaps? I wonder if the limit switches use a common pair. No, they don't. They've got all their own limits. Oh well, again, doesn't need to be He-manned, pretty much self-explanatory. So I guess that's why they kept the cost of this kit so low, because there's no pre-built controller. And the benefit of that is whoever builds this understands their machine better. You see how it goes together, and there we go. So I'm just going to nip that gland up for the USB cable. Just want to provide enough slack not to put any force or undue stress on that USB connector. Although it seems to be reinforced through the chassis of the USB connector to the board, just be mindful that we don't need to put too much stress on that. Okay, well, we'll see what's next. Okay, so this is probably going to be the last step on our control box until we have the machine assembled and all the other cables run, because we have to then be concerned with the stepper motor cables coming in, the limit switch motors and whatnot. So, and then the internal wiring of the other switches, the e-stop, the resume and feed hold. So what we'll do now is just feed in the power supply, because we know that's the only thing that we can do now rather than before the machine's finished, and terminate it to the power input, which I believe is this one at the end. So it's just a plus minus, and it's a two pin socket, this puppy here. So what I tend to do, plug it in. It's keyed, so you can only put it in one way, and you can see that we've got half rounds, a rounded section on, a bit of put in the shot. Just may be able to make out there's the half round sections there, and the corresponding half rounds on, well, not actually quite half rounds, they're probably quarter rounds. But anyway, that will locate into the socket until you get a nice little firm click, and then we can take note of the orientation when we get our power supply. We've got a short sort of pigtail end, which is our output, clearly marked here, our output, and we can put that through the small cable gland, taking off the cable nut, putting that on. Got to keep in mind there's a silicone seal, or rubber, depending on the makeup of it, making sure that stays within the socket. And then we can put, I've just got to find a flat blade screwdriver. We can see the silk screen's marked with positive and negative, a positive to the outside of the chassis and a negative towards the center of the box. So we'll do that and then securely fasten that. We're good to go. When securing the cable into these connectors, make sure you back the screws off first, because the receptacles for the socket themselves are closed, and don't be fooled, because if you put the cable in before doing so, you would think that you're actually undoing the clamp portion of the connector, but not actually clamping anything. So you have to make sure you back them off first. Then we'll put our wires in. Now push them in as far as they'll go. The general rule of thumb is you're not supposed to see any conductor material, and you're not supposed to put the insulating material into the socket as well. So you might be able to tell. What I might do is zoom in so you can see what's going on. There we go. Even though I'm pushing in, and it appears that the conductors are bottoming out from the base of the socket there's still an undesirable amount of conductor showing. Even though these are tinned, probably not the best idea. I'll go get my side cutters, and you can see there's probably about 3 millimeters or 1/8 of an inch still visible. So we'll trim that amount off the end, maybe a little bit less. 1, 2, making sure they're not inside the box. Try again. And then now we can see, you can just see the base of the insulation, and that's acceptable. Now we can nip up the clamps, and you can feel, as you tighten them up, you can feel the cable being dragged towards the screw, meaning the clamp's coming up behind it and pulling it in. Same again on that one. And then if you want to, you can unplug it, get a better position, and just give them a nip up. Not too tight, just about a 1/4 turn after it goes tight. And then we have the power connected. Same again, just give this a little bit of, so there's no stress on the port itself, and then you can nip up the cable gland, just finger tight. There's no need to get tools on it, just nip it up finger tight, that's all you need. And that's the power supply. Okay, that sort of gets us to our conclusion on the control box so far. Once we get the rest of the machine built, we'll need to revisit this and enter all our motor wires and our limit switch cables, and then finish wiring up the internals. But it's a pretty neat little package. And yeah, so we'll be back later with the commencement of the actual machine platform being built, and then we'll revisit this guy when we're ready to finish wiring. Thanks for watching.